Ultrasonic walking stick with voice assistance for the visually impaired. The primary aim of this project is to develop an advanced blind stick robot that enhances mobility, safety, and independence for visually impaired individuals. Traditionally, white cans, while widely used, offers only limited tactile feedback, requiring physical contact with obstacles before detection. This means user must rely heavily on their other senses to navigate unfamiliar or hazardous environment. Furthermore, traditional mobility aids do not provide preemptive warning about potential dangers such as obstacle, wet surface, or moving objects, nor do they offer emergency assistance in case of distress. To overcome these limitations, the blind stick robot integrates sensor-based obstacle detection, water detection, GPS tracking, and voice guidance, ensuring a more advanced and efficient navigating aid. This smart system leverages modern IoT technologies, microcontrollers, and communication modules to enhance user experiences by facilitating real-time obstacle detection, emergency support, and hands-free operation. By integrating these advanced technologies, the blind stick robot aims to provide a comprehensive user-friendly mobility aid that empowers visually impaired individuals to navigate their surroundings with greater ease and safety. Unlike traditional white cans which rely solely on physical contact with obstacles, this smart system offers proactive hazard detection, voice guidance, and emergency communication features, making it game changer in assistive technology. Central Control Unit ESP32 microcontroller. ESP32 microcontroller acts as the brain of the system, processing data from various sensors and triggering appropriate responses. It continuously monitors sensors input, makes real-time decisions, and activates alert as required. The ESP32 microcontroller plays a crucial role in an ultrasonic walking stick with voice assistance for the visually impaired. This project, it acts as the central processing unit, handling sensors inputs, outputs, processing data, and triggering appropriate outputs like voice alerts or haptic feedback. At the end, ESP32 in an ultrasonic walking stick acts as the brain, combining obstacles detection, voice guidance, wireless communication, and power management to provide an efficient assistive device for visually impaired individuals. Its processing power and connectivity make it an ideal choice for such an IoT-based assistive systems. Incorporating GPS Global Positioning System and GSM Global System for Mobile Communication in an ultrasonic walking stick can significantly enhance its functionality by providing real-time location tracking and emergency communication. The GPS module is used to determine the user's exact location via satellite signals. The ESP32 communicates with the GPS module over serial communication to retrieve latitude and longitude coordinates. Navigation assistance: if the walking stick is connected to the smartphone, the GPS can help in guiding the user to a destination. If the user is lost or in distress, their location can be sent to a guardian or emergency services. The GSM module allows the walking stick to communicate via SMS or calls. Send an SMS alerts with the GPS location when the user presses an emergency button. Make an automatic call to a predefined contact. A family member can send an SMS command to the stick and it will be helped with the user's GPS coordinates. Here we are looking for sending an SMS message to the guardian or a caretaker. This is a speaker for ultrasonic walking stick with voice assistance. A speaker in an ultrasonic walking stick is essential for providing auditory feedback to visually impaired users. It allows the device to communicate obstacle warning, navigation instructions, and emergency alerts through voice assistance. When an obstacle is detected by the ultrasonic sensor, the ESP32 triggers the speaker to say obstacle detected, and if the water is detected in a surface, it will say water detected. This is the purpose of speaker in the stick. A display in ultrasonic walking stick enhances the device usability by providing visual feedback for the user or caregivers. Although the primary user are visually impaired, a display can still serve useful functions such as showing system status, emergency signals, etc. It will signal the user by object detected or water detected. A water sensor is an important addition to an ultrasonic walking stick as it helps visually impaired user detect puddles, wet surfaces or flooded areas, preventing accidents such as slipping or stepping into water. The ESP32 can process water detection data and provide alerts via voice output, vibration or a buzzer. Here we are using voice assistance. And the sensor probes detects the presence of water and sends signals to the ESP32. The ESP32 reads the sensor output and triggers can alert if water is detected as water detected through the speaker. Integrating a water sensor into an ultrasonic walking stick enhances safety by preventing users from stepping into puddles, wet surface or pets. The ESP32 processor the sensor data and provides voice, vibration or buzzer alerts, ensuring a safer walking experience for visually impaired individuals. A emergency button in an ultrasonic walking stick is a critical safety feature that allows visually impaired user to quickly request help in case of an emergency. Pressing the button can send an alert, share the user's GPS location or trigger an audible alarm for immediate assistance. User presses the emergency button, ESP32 detects the button press, reads GPS coordinates from the GPS module, send an SMS alerts to a predefined number via GSM module. If required, the ESP32 can repeatedly send alerts at intervals until help arrives. The emergency button is a life-saving feature in a smart walking stick. It allows visually impaired user to quickly call for help by sending GPS-based SOS alerts, activating alarms, and notifying caregivers. The ESP32 processes the button press and ensures fast communication using GSM and GPS modules for enhanced safety and independence. The ultrasonic sensor HC-SR04 emits high frequency sound waves and calculates the distance based on the time taken for an echo to return. If an obstacle is detected within predefined range, the ESP32 triggers an audio warning through the voice module ISD 1820 and speaker 5 watts audio. This allows the user to avoid obstacles before physical contact. The ultrasonic sensor is the core component of the smart walking stick, used to detect obstacles and provide real-time navigation assistance for visually impaired individuals. It works by measuring the time taken for an ultrasonic waves to bounce back after hitting an object, allowing the device to calculate the distance of the obstacle. The ultrasonic sensor is a vital component of walking stick, ensuring safe navigation for visually impaired user. It helps detect obstacles and provide feedback via sound speakers, enhance user independence and safety.
Object detected. Water detected. Water detected. Emergency.